Hello. Good morning. I know that it's been like a month since I've streamed, but here we are, and I'm streaming the wrong thing on the wrong day. Yay! Anyway, I wanted to keep momentum and start on a project that I am very interested in completing, and I will tell you that I will probably no longer be completing this project only on stream. I am very interested in making some significant headway into this project. So, that being said, where we're at is we are in the project tracking potential solvent interactions. This is a project that I started in, let's say, 2011. And this was like the fifth independent research project associated with that. And I have managed to get my old GC data. That's gas chromatograph. It's a chemistry project that deals with extracting a particularly uh, gnarly analyte from soil, and we started experiencing some very strange occurrences as we were trying to study this thing. Basically, what we found out, or what we suspected, is that our solvents were reacting with this bicyclo chlorinated ether. For those of you that know chemistry, oh, and it also had an alcohol group on it. For those of you that know chemistry, you know what I just said means that there's all sorts of opportunities for various reactions. And we were trying to find a solvent to perform this extraction, and we ended up using isopropyl alcohol, and I think that it started reacting with the ether. We ended up with oily mixtures that were separated, and anyway, I want to see if I can use the skill set I've learned in machine learning since that point in time to figure out if we had a reaction or not. And we can do that by looking at the various variables that we have, and that's kind of what we're setting up right now at this point in time. Some streams I go over this Trello layout. That's what this screen that you're seeing is right now. We have different cards and different tasks that we have to perform, and they're written in an agile type format with something called story points. Basically, the size of our current sprint is, or the size of everything in this card is 50. And we have done or spent 28 of those points, and we have 22 points remaining. You could say that we have done more than we have left to do, which is kind of great. And you can see here we've completed some things already. Today we are going to be focusing on managing NaNs, managing duplicates. Oh, this is cool. Trello recently had an update, and I just had to vote on whether or not I like the new colors, but I like this because this was driving me bonkers because I couldn't see what I was supposed to do. So with managing NaNs, as a data scientist, I want to manage NaNs so that feature exploration and statistics and models don't break. When I view the interim process data, there are no NaNs present. And so that's the first thing that we're going to be doing. And I'm hoping to get these for manage NaNs, manage duplicates, manage infinite numbers, drop unnecessary data. And then this ensure data is prepared for a future model. That has a lot in it. And then here you can see we have an additional sprint. You can see that we are way past the start dates of these sprints, but that is okay. That just means that our managers told us we need to do things. That manager is me. Ha. Ha. Okay, so we're going to start with managing NaNs. And we are in our first notebook still. We're importing and scrubbing once we've scrubbed and can export our modified data to a series of CSVs. We will be doing so to keep our notebook size down. You can see here our scroll is already like really small, and that is a problem. However, we only have 62 cells worth of code. I don't want to say lines because, as you can see here, that line can be much longer. Okay, so we want to insert cell above. You can see that the hotkey for that is A for above, and we are going to immediately regret everything because we want this header to be ahead of what we're doing with NaNs. Give it to me. Why won't you move? Okay. Come on. You're supposed to be able to move. Ugh. You're supposed to be able to just drag and drop these things. It's not kernel. Move cell up. And now there's no hotkey for this. Move cell up. Can I do it now? Nope. Nope. No drag and drop available. That's really annoying. Okay. Let's see here. That's fine. Okay, what we are gonna do right now, we are working with this data frame called conks, I do believe. And we stripped our column names, checked for everything. So we have cleaned column names. That's pretty great. We have checked for object type data. And we fixed some because there was some object type data, if I remember correctly. Okay. External data sources. Is this where I added? Yeah. Okay, we're gonna fix that here in a little bit. That's not external, those are internal data sources that I wanted to add. After we went through and figured out some of this trial business, we just did a kind of cursory glance at our data structure. And then here, we went through and determined what was in our data, pulled down, we have communicate and create space for our data structures, and I do believe, now you can see our scroll bar is much better. However, not every person that downloads this notebook will have this capability. This is like an extension in Jupyter Notebooks that I like because I end up making really long notebooks, unfortunately. Okay, it's just quiet music right now. I apologize if y'all cannot hear it. Oh yeah, you can. Got a nice little beat. Okay, so I'm looking for the name of our, yeah, we are in the conks. Just because it's been so long, then I wrote a neat little function that will work for our list of data frames to check every header. And I'll be doing something similar for the NaNs. So the first thing that I want to do is print length of conx, which is short for concentration. Okay, cool. And then I want to do conx 0 dot is an A, which is a nice little Python function, and then sum. Okay, and this will give us a list. And can I do dot sum again? Dot sum. I can. Okay, that's cool. That's what we want. Okay. Now we need to put this into a for loop to do it to our uh, entire list of data frames, which has 63 data frames in it. Okay, so what we want to do is we want to print this length. Let's go ahead and set up our for I in range 0 to length of our data frame. We want to print the length of const I. We also want to print I. I think I want those to be on the same line. So we want to print I plus the length of that data frame. And then we want to print const I dot is in a dot sum dot sum. Okay, cool. So it looks like we have no NaNs present in our data frame. That is fantastic. I could go into a whole thing where we set up this function that reads if there are NaNs present, like we just did, and then goes through this decision tree afterwards about what to do if there are NaNs present and what to do if there are not NaNs present. However, I don't want to do that. Um, this is the only time I'll be doing this particular thing, but what I will do is write a function here that goes through the same thing. I think, honestly, let's, hold on. Let's do that there, this here. I'm trying to remember. I want to keep my code integrity. There we go. So we did this first, and then we did this. And by that, I mean just trying to keep my thought process in the code. So this particular cell block checks the first item in, or the first DF in list of DFs for NaNs. This is kind of like a proof of concept for method dot is NA. Next page, please. More music time. By page. Okay. And then here, moving forward in that process, instead of just checking that the method works for one instance, here we are applying apply proof of concept to entire list of DFs, which is what we're doing here. And now we are going to functionize our application. So we're going to call this stuff check for NaNs. And we need to pass in our list of data frames. And here we are, this function will return the number of NaNs in each data frame. I'm gonna say, given a list of this function will return the number of NaNs in each data frame given a list of data frames. Okay. And we have our docstring there now. And we want to copy. We're going to modify this slightly to fit within our function here. Length, this is going to be data frames. And this is not going to be a print value. We are going to return these values. And we're going to change this to data frames I. We're actually going to get rid of that one. And we're going to change const to data frames. And now we're going to test this here. Test new. Check for NaNs function. Just by running, let's see what happens. Check for NaNs. We're gonna pass in const. Let's see. Okay, so it just does the last one. That's not exactly what we want. Okay, so we're going to set up a num of NaNs list. And instead of returning here, we are going to append. It's going to be num of NaNs dot append data frames I with a sum, and then we are going to return this num of NaNs list. And now let's check it. Okay, that's great. So now we have this number of NaNs, and we know that they're in order. We'll return the number of NaNs in each data frame. I'm gonna put this kind of like as an addendum. The returned list will be in the same order as the list that was passed in. That way you can have a reference in case one of these numbers ended up being like a 1. You could, you know, it's kind of like creating like an index in your head, saying, you know, if this 15th one here, I don't know if that's 15th or not, but this 15th one and this list here will match up with the data frame that's 15th in the original list. That way you can make modifications as necessary. And that's honestly, that's it for check and manage NaNs. We checked for them. There are none present, which is great. In fact, there are none present for every something fun that we could add in here as well is print data frames I dot is NA dot sum. We know that there are no NaNs for every column here. and we can go through all 63 data frames and kind of just scroll with our eyes and see if there's anything that's not a zero. We get the full printout here. And that's something that might end up going into like a report, if there were to be like a list of NaNs or something that were needed. That's something that I might do if I found not a number present. However, we don't have that. We just have this 63 long list of everything being zeros, which is great. So that means we are done with this managed NaN. So we are going to actually decrease our story points here because it was really easy. And we're also done with this task. So we're going to change this label to done instead of to do. We're going to go into our sprint. We are going to look at our card size. We're going to decrease our total size by 2, and we're going to spend 2. Because we had 4, and then we moved it down to 2, and we completed that task. Did I check it off? No. There we go. Okay. The next thing that we're going to do is we are going to check for duplicates. We have our acceptance criteria here. Okay, I'm just double checking. That's what we're doing now. Cool. Okay, we want this to be a markdown cell. We're going to add this here. And the title of the task that we're doing right now is manage duplicates. So, and I do believe, there we go. Now that's set up just like our managed NaNs. We did not modify our list after NaNs. So we're going to be using the same one. The first thing that I do, it's going to be really similar. We're just going to have a proof of concept for checking for duplicates. And what I normally do is I have this this text that I print out, duplicated rows. So we checked our columns to make sure that all of our NaNs were present. For duplicates, we're actually going to be going row by row to see if there are any duplicated rows. We're still checking each cell, but instead of like with the NaNs, we checked column by column. With the duplicates, we're checking row by row. And I do this by looking at our data frame dot duplicated dot sum. It appears that we have no duplicated data. This is not a surprise to me. I went through and validated the data integrity before I did any imports or anything like that for this project, because I have the fortune of having that crossover knowledge between chemistry and data science. Something that's fun is, so this is just like the basic code. You can actually print the length of your data set. This reminds me of the Labyrinth a little bit. That scene at the very end with the baby and the room full of stairs leading to nowhere. Wow, cool. Okay. You can print the length of your data frames before. Then you can check to see if there are duplicated rows and then have those printed out. And then you can actually do the drop. It's not DF. I am looking at a past project where I did this. Dot drop duplicates. And we're going to do in place equals true. That way it returns the same data frame just without the duplicates. There are cases where you don't want to do that. However, we have our raw data saved, and we also have some like interim stuff right now as well that's saved. So we don't necessarily need to worry about it. There are some instances where you absolutely want to worry about it. Then we can print our length of our in place dropped data frame. And then we can also print my little line of text where I do duplicated rows plus. And what this does is it just provides the user with kind of a comprehensive view of what happened to their data. For instance, in the project that I'm looking at, I have 19,600 duplicated rows. The length of the data frame before I dropped was 27,581. 19,000 rows were duplicated. So after I dropped all of the duplicated rows, I ended up with 7,981 rows of data. There's a significant difference between 27,000 and 7,000. So here you can see that we have 1,401 lines of data, or rows of data. And we don't have any duplications, so our data frame length stays the same. Now there's here we have this proof of concept. Now duplicated rows. Let's do print number of rows before. Let's do, and then let's do that. Here, let's do number of rows after. And then I think we can take this and put this here. And then we can get rid of that. And then here, I think we can do the same thing. And this just kind of cleans stuff up, makes it a little bit more Pythonic. Let's do. Let's do str. And this is a plus. Get rid of that. Let's see how that looks. Oh, we have to have a plus here as well. Okay. This should be, let's do a colon. Yeah, I like that better. Okay. So we're gonna do that. Then we're going to have a plus, and we're gonna add str to turn this into a string. We're gonna add a plus. Then we're gonna add a see what that does. There we go. Okay, duplicated rows before, duplicated rows. Let's add. Let's get rid of this before. That's unnecessary now that we're on the same line. Let's do the total number of rows before. And again, right now what I'm doing is thinking about that report that I'm going to have to write because I modified the data in some way. I want to show the work that I was able to do. So this is the proof of concept for one singular string. Now let's apply one singular data set. Proof of concept to list of data frames. So for I and length of, let's do in range of 0 to length of our data frame. Let's do the same thing here. Except for conc 0, we're gonna do const I. And what I want to do here is I want to print I so that I know what number of data frame we're working with here. So we have duplicated rows. Everything, again, is 0. And part of that is because I was able to vet the data beforehand. That's great. And again, this is something where we could write a function where if this const duplicated dot sum or data frame dot duplicated dot sum returns a value that is not 0, we can throw a flag. But that is a little bit outside of the scope of what I want to do for this project. Again, I want to get to actually munging data. I want to get to the deep depths of this project. So I'm gonna leave this here for now. After I write a function. Now in this function, we're gonna do the same kind of type thing where we're gonna return probably 2 lists. And that is going to be a list of data frames where there was a duplicated row. No. Let's just fix it. Let's just return a data frame that has the rows dropped because you don't want duplicates. Whenever you have duplicates in your stats, it kind of gives a double weight to that one row that's been duplicated. And if it's been duplicated like 6 or 7 times, then it gives 6 or 7 times the weight to that one value. And that's something that we don't want. We want everything to have an equal weight going in. That way we can actually look at accurate statistics. So we are going to write a function that removes or remove duplicated rows. We want to pass in a list of data frames, and this function will remove duplicated rows of data given a list of data frames. The return value will be the list of data frames with all value or all duplicated rows removed. There we go. Here's our doc string, and now I know, because we're returning a list of data frames, this is going to be duplicates removed. And now we're going to kind of set up our for loop for I in range of 0 to length of data frames. We want to do duplicates removed dot append data frames I dot drop duplicates in place equals true. There we go. And we should end up with that list. Duplicates removed. Here we are functionizing proof of concept with lists. But we're not, in this case, we are not getting any information back in that report by using this function. That is something that I would want. So we can add it in here. We can have duplicated equals and then just not return it with our function at this point in time, meaning this functionality is not going to be present in our encode, but it is present should we want to instantiate it. So we are still going to be with this I in range. We want to look at here. It's going to be if data frames I dot duplicated dot sum does not equal 0, then we know that we have a duplicated value. Duplicated dot append, and we're just going to put I. Then we're going to do else not duplicated dot append I. And that way we could return our duplicated list, our non-duplicated list, and our data frame that has, or a list of data frames that has everything clean. Supposedly, if we add the length of duplicated and not duplicated, we should end up with the length of the original data frame. So we're just gonna leave that in there. We want to return duplicated, not duplicated, and duplicates removed. So this is just a basic list. This is a basic list. This is a list of data frames. The return value will be a list with the place in the data frames list passed in with the place of for data frames that were duplicated, then a list for data frames that had rows that were duplicated, then a list, then a similar list where rows were not duplicated, and finally a list of data frames with all duplicated rows removed. And now we should be able to use this function here. Let's get duplicated, not duplicated. And then we're just going to call this concs again, equals remove duplicated rows, where we pass in the value of concs. Let's see what happens. We should get, this should just be an empty list for us. Great. Then not duplicated. Should be a list of everything. That's great. And then let's do concs should be that's a problem. We erased all of our data. How do we do that? Okay, now we get to let's actually, under kernel, you can do restart and run all. That's what we want to do. Basically, our concs variable got emptied, as you saw. It was filled with none values, and then when we popped up one, there was nothing in it. That's a problem. We actually want our data to be present. And so what I did is I restarted our kernel to kind of repopulate everything. We can see here that we have our full gambit of data. Here we have our duplicated, not duplicated, and then here we have nothing. That means that how we've written the function won't actually work. However, and it worked completely fine here. Drop duplicates. Let's set it up this way. Let's go. New df equals data frames and then let's just put UDF here. And let's see if that fixed it. Now remember, our data is actually currently empty, so we're gonna go to kernel restart and run all. And wait to see if our data is emptied again. Drop duplicates. Drop duplicates. I wonder if we take away this in place true option. So I know before that in place true means if you're keeping the data frame the same, we're actually changing what variable the data frame is stored under. So maybe that's why we're ending up with an empty data frame. Yeah. Yeah, that's why. Okay. So what if I change this data frames I? What if I put this here? Kernel restart and run all. Okay, that's great. Okay, cool. So there's our proof of concept there for managing duplicates. The next thing, so we've officially managed duplicates. We have a function to do so. So we are done with this task. I'm going to leave this at 4 just because we had to do a little bit of troubleshooting. Card size, we have spent all 4. We're changing this label from to do to done. Did I change? I did not. Card size, this is done. Cool. And now we have spent 4 more story points. We are done managing duplicates. Now we are going to look at managing infinite numbers. As a data scientist, I want to manage infinite numbers so that future statistics or modeling does not break. When I view the process data, there should be no infinite numbers. Okay, cool. So I'm going to change this into a markdown, manage infinite numbers. We're going to copy that. Okay. Okay, I'm looking at my old project to see if I checked for infinite numbers, and I did not. So I'm gonna do a quick Google on how to check for infinite values using pandas. This is going to be a lot like our, there we go, NaNs. So much so that I'm going to copy paste so I don't have to type as much. For infinite numbers proof of concept for method dot is INF. What? Okay, I'm gonna type this out. Print length. Const 0. Object of type method has no length. Object. What? So after we manage duplicates here, our const 0 bound method. How do we make this into a data frame? Can I just pd.dataframe it? If index is none or columns is none. What the crap? Okay, so this is now a bound method. Dataframe dot drop duplicates. I don't know why. Should we... New df equals data frames I dot drop duplicates. Can we say this as our new df? So again, our data source here has been augmented inappropriately, so I'm going to restart and rerun everything. Const before, just data frame. Const after, we still get this bound method stuff. Okay, let's do this. How to fix, I'm Googling, bound method data frame drop duplicates. Now do I put the in place? Oh, wait. Actually, I wonder if that would do it alone just by adding in the parentheses. Mm. Okay, this is an actual data frame now. That's good. Data frame has no object is infinite. Okay. So we fixed that. That's good. Use data frame dot is INF to check. It's a function. And it's supposed to work. Okay, so pandas doesn't check for infinite numbers. NumPy does. Do I even have NumPy installed in this library yet? No. Cool. Okay. We want to import NumPy as an NP, please. Then I wonder if I can just NP ah? Ah? Will it work? Oh no. I was afraid of this. Okay. Okay. Because data frames are not arrays. Arrays are only one column. We could probably do time in minutes. No? Okay. Let's do let's find the proper is INF. Okay. NumPy. Array like value. Out. Where okay, so we don't have to array it, we just have to We don't even need this. I don't think that works. Yeah, that doesn't work. Oh, okay. We have to do conks that to numpy. And then we should be able to okay, so I'm looking at the documentation. Look. This is what I'm looking at. NumPy is infinite. Pandas data frame converted to NumPy array. Applying NumPy array. Our input is supposed to be array-like. And it's saying it doesn't exist. So we are gonna look up this particular attribute error in our Google and see what Stack Overflow has to say. I want exactly this error, Google. No results found. Why is my life like this? It must have a shape that the numbers broadcast to. Out. This is optional. Where is optional? Everything here is optional except for the input value. Oh, this is finite. Optional. Ah! Does this even work? That works. Cool. Is it at the front? It is at the front. Okay. Now we should be able to do dot sum. Yeah. First off, is this a list of lists? Yes, it is. So do I do dot sum here? No, I should not. Okay. I want to return it. I guess it doesn't matter. But it would be nice if we could get it the same way that we had the NaNs, which was by column and then by data frame, not just by either every value that exists or... Yeah. Uh, okay. I guess that would be for I and range 0 to length of this. We could do Cox 0 I got some, maybe? Every value. It's not exactly what I want. Um... Okay, so this went row by row. I think I'd have to do like 0. It'd be everything, and is that right? And could I get the length here? Yeah. Let's do, instead of that, let's do that shape. Yeah, so this is one column. Then if I did to 1, if I did to 2, yeah, okay. Yeah. Okay, so this is kind of what I'm looking for here. This would do every column, I do believe. Yeah. Okay. So this would be MPy Cox 0, which we are turning into a NumPy array for the purposes of this. 0. What's the length of this? We should check to see if that is equal to const dot columns. Const 0 dot columns. Let's get the length here. True. Okay, yeah. Okay. So I'm gonna type in this should be the first column of information and the first data frame. This particular reference is set up to be the first row of data. So if we want to get the column information first and then do the summary afterwards. Honestly, we could just do the sum of the whole thing and it would be the sum of the whole thing. But if we wanted column information first and then afterwards do something a little bit different, then this is how we would do that. I actually am going to need to stop the stream here today. So far we're in the middle of managing infinite numbers. We have found out how to do it, which is by converting our pandas data frame into a NumPy array and then applying the NumPy method is infinite to the entire data frame. And what that returns for us is a long list of everything in that data frame, if it's an infinite number or not. We looked at a way to reference to get the rows and columns to figure out kind of how they work. Our rows, of course, are in our first space, and then our columns are in our second space. If you've never worked with NumPy arrays before, that's generally the format of how they function. You get the row information and then the column information. We need to apply this to our entire list of data frames to ensure that we get out what we're expecting. And then we need to functionize that to finish the manage infinite numbers. Now, I did mention that I wanted to get the manage NaNs, manage duplicates, manage infinite numbers, and the drop unnecessary data done today. However, I'm having some health issues at the moment, so I'm going to stop the stream here, take care of what I need to take care of, and then probably finish these two tasks up in my free time. I want to be done with the scrub. I want to export our data so that we can start exploring, and I'm very excited to do that. Thank you so much for listening to this video later if you check out the recording. If you have any questions, feel free to put them in the comments, and I will see y'all next time. Bye. Okay, it's a lot of